one of the most fascinating objects in the universe, our sun. It's the star at the center of our solar system, the source of light and heat that makes life possible, and a cosmic powerhouse full of mysteries. Let's dive in. The sun is about 4.6 billion years old, formed from a giant cloud of gas and dust. It's classified as a G2V star, a yellow dwarf, which means it's a main sequence star of medium size and temperature. Even though we call it average, it's anything but small. The sun contains 99.86% of the mass of the entire solar system and could fit about 1.3 million Earths inside it. At its core, the sun reaches temperatures of around 15 million degrees Celsius. Here, nuclear fusion takes place. Hydrogen atoms fusing to helium, releasing enormous amounts of energy. This energy slowly travels outward, taking thousands to millions of years to reach the surface. By the time it arrives at the photosphere, the visible surface, the temperature is about 5,800 Kelvin or approximately 5,500 degrees Celsius. The sun doesn't have a solid surface. It's a ball of plasma, superheated electrically charged gas. Above the photosphere lie the chromosphere and the corona. The corona is puzzling. It's far hotter than the surface, reaching millions of degrees, and scientists are still trying to understand why. This outer atmosphere produces solar wind, streams of charged particles that flow through the solar system and can trigger auroras on Earth. Rotation on the sun is tricky. Because it's made of plasma, different parts rotate at different speeds. At the equator, it completes a rotation in about 25 Earth days, while at the poles, it takes about 36 days. The sun is dynamic. It produces solar flares and coronal mass ejections, massive bursts of energy and particles. These can disrupt satellites, power grids, and communications on Earth. Studying them is crucial for space weather forecasting. Missions like NASA's Parker Solar Probe and ESA's Solar Orbiter are helping us get closer than ever to the sun to unlock its secrets. Composition-wise, the sun is about 91% hydrogen and 8% helium, with traces of heavier elements like oxygen, carbon, nitrogen, silica, magnesium, and iron. These elements were forged in earlier generations of stars and were cycled into our sun when it formed. The sun also orbits the Milky Way galaxy, traveling at about 720,000 kilometers per hour. It takes roughly 225 to 250 million years to complete one orbit around the galactic center. Without the sun, Earth will be a frozen and lifeless rock. Its energy drives our climate, weather, and ecosystems, but it's a delicate balance. Too much solar activity can be harmful, while too little would plunge us into an ice age. Looking ahead, the sun will shine forever. In about 5 billion years, it will exhaust its hydrogen fuel, expand into a red giant, and eventually shed its outer layers, leaving behind a white dwarf. That's the long-term fate of our star. So next time you see sunlight streaming through your window, remember, those photons began their journey in the sun's core millions of years ago. They traveled through layers of plasma, escaped into space, and finally reached Earth, powering life, technology, and our very existence. Thanks for watching this deep dive into the sun. If you enjoyed learning these facts, hit like, subscribe, and share this video. And tell me in the comments, which sun fact surprised you the most?